Okay, students, on this clip we're going to go over how to solve um, exponential equations using the worksheet that I just handed out to you. So let's go ahead and start with question number 1. The ultimate goal is to get the bases the same so that we can use logarithm to eliminate the exponents. Remember that the opposite of log is exponents, okay? So we have 9 to the negative p here. Can I break down 9 any further? Let's see. I can break down 9 into 3 times 3. So basically 9 is 3 squared. So instead of writing 9 to the negative p, let me write it over here. 9 to the negative p equals 1/3. I could just change 9 into 3 squared. 3 squared. But wait, there was a negative p here before. So I need to encapsulate that in the negative p, the parentheses like this, equals 1/3. Alright? But this is 1/3. 3 is to the first power. I can't break it down any further. So I'm going to reciprocate this, okay? Because I need it on top. So when I reciprocate it, the power becomes -1. Alright? Now when I multiply the exponents, I'm going to have 3 to the negative 2p equals 3 to the -1. Now the bases are the same. Okay, the exponents, these are the same. So now I'm going to eliminate them using logarithm. Okay, I'm going to use log base 3 on the left of what? 3 to the negative 2p on the right side equals the same thing to preserve equality, log base 3 of 3 to the -1. What does that allow me to do? This gives me the right to cancel because log and exponents are inverses, right? So on the left side, these two cancel out. On the right side, these two cancel out. So you're left with -2p equals -1. To isolate p, simply divide both sides by -2 and -2. And your final answer p is going to be 1/2 because minus over minus is a plus. Alright? So you can just slash and dash, and the answer is p equals -1/2. Alright? Answer for number 1 is B. Alright, let's move on to question number 2. I'm going to erase this first. Question number 2. Which is basically 64, this one right here. So to do this one, we need to express the basis as the same number, okay? So I'm going to take 64 and break it down, and then I'll also break down 16. So if I take 64, 64 is basically 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. So 1, 2, 4, 6. So 64 is basically 2 to the 6th power. And 16, you can see 16 here is 1, 2, 3, 4. 16 is 2 to the 4th power. Alright? Just use your factor tree to break them down. So we're going to use this idea to solve this equation. Okay? So in this equation we have 64 to the 2x equals 16 to the 2x. Now instead of 64, I'm going to write 2 to the 6 and then times 2x, like that, equals, instead of 16, I'm going to write 2 to the 4th times 2x. You see, these powers were there before, so that's why I'm putting them in parentheses. Now we're just going to multiply this to that, multiply that to that. So it gives me 2 to the 12x equals 2 to the 8x. Now to eliminate these exponents, I'm going to use the inverse of exponents, which is log, right? So I'm going to take the log of both sides. I'm going to take log base what? To eliminate it, I need to take log base 2 because we have a 2 here and a 2 here. So log base 2 of the left side of 2 to the 12x. And then on the right side, log base 2 of 2 to the 8x. Okay? On the left side, the log and the base, this cancel out. you're left with 12x. And on the right side, these two cancel out. You're left with 8x. Alright, to finish this up, we're going to have to move all the x's to one side, right? So I'm going to subtract 8x from both sides, subtract 8x, subtract 8x, and then that's going to give me 4x equals 0. Divide both sides by 4, and your final answer is going to be x equals 0. Alright, so your answer is D. Alright, let's move on to number 3 and see how we can use these cool properties to basically solve logarithmic, exponential equations. Let's take a look at number 3. So number 3, we want to get the bases the same, right? We need 16 first. We need to break down 16. If we look at the other example, 16 was 2 to the 4th power, right? 16 is basically 2 to the 4th power. And 2 just stays as 2 to the 1, it doesn't change. So in this problem, we have 16 raised to the power of 2m plus 2 equals 1 half. So how do we do this? We need to make the bases the same, okay? So this one in its simplest form is 2 to the 4th. But wait, there was something there before. There was a 2m plus 2 there before. Okay, so we're going to put that there in parentheses. And then this 2 is 2 to the 1. It needs to be upstairs. So when we reciprocate it, it makes the power opposite, like that. Okay? Now, we can go ahead and distribute this 4 to both terms. So we're going to have 2 to the 8m plus 8 equals 2 to the negative 1. Now how do we get rid of the 2's? The legal way to do this is by taking log raised 2 of both sides. Log raised 2 of 2 to the 8m plus 8 equals log base 2 of 2 to the negative 1. Alright? So that cancels out with that, and that cancels out with that. So we have 8m plus 8 equals negative 1. Alright? So I'm going to solve this. I'm running out of space. So I might have to erase. I'm gonna jump up here. So we're gonna do 8m plus 8 equals negative 1. So to solve that one, what I'm gonna do is I'm going to subtract 8 from both sides. Subtract 8, and then we get 8m equals negative 9. Divide both sides by 8. And your final result, m equals negative 9 over 8. Alright? So our answer for this one is D. Alright, now I'm going to jump to number 5. It seems to be slightly more complicated. And then I'm going to have you guys work on the rest. Alright? So let's take a look at number 5. What was that? So for number 5, we have those two there. So I like to express them as the same base, right? So 64, we did that just now. It's 64. If you look at the example we just did, is 2 to the 6th power, and 16 we also did is 2 to the 4th power. Okay. So if we want to rewrite this, we can rewrite this problem as 1 over, instead of 64, 2 to the 6th raised to the negative 2r plus 1 equals 1 over 2 to the 4th raised to the negative 2r. Okay? Now I need these two to be the same base, so I'm going to reciprocate both of them. Okay, so if I reciprocate these two, I'm going to have 2 to the negative 6 right there. And then that times negative 2r plus 1. And then on the right side, I'm going to have 2 to the negative 4 times what? Negative 2r. Okay, this just went upstairs and became negative, and this 2 went upstairs and became negative. Alright, so all I'll do is distribute this to this and that, and distribute this to this, okay? So we're going to have 2 to the 12 minus 6, I'm sorry, 12r minus 6. 12r minus 6. And on the right side is going to be 2 to the 8. Okay, remember minus times minus is plus. Alright, so to finish this up, we're going to get rid of the exponents by using its opposite, which is logarithm. So logarithm base 2 of 2 to the 12r minus 6 equals log base 2 of 2 to the 8r. Okay? On the left side, log base 2 and 2 cancel out, so we'll have 12r minus 6 equals, on the right side, log base 2 and 2 cancel out, equals 8r. Alright? Okay, to solve this, we can move 12r to the right, and then divide with, and then go from there. So subtract 12r from both sides, because the r is already there. That gives us negative 6 equals negative 4r. To finish this off, we just simply divide both sides by negative 4. Divide this by negative 4. And divide that by negative 4. So for this one cancels out. So have r, if we divide it, equals 3 over 2, because 2 goes into these two. You divide this by 2, divide that by 2, and then you get 3 over 2. Okay? There goes your answer. Answer for C. Sorry. Answer for number 5 is C. Okay? Alright, so hopefully this example has helped you out. I'm going to have you all work on the remaining problems. Alright?